What's up, everybody? We're right here at the San Francisco AI Conference Hack Day, where we're bringing together some incredible companies from Strands Agents from AWS, Neo4j, Vappy, Weaviate, Sovereign, Friendly, and CodeRabbit. With these tools, developers are going to build some incredible projects, and I'm really excited to see what they do with it. Right now, we're walking through the space. We've got about 850 registrations, of which we accepted close to 600. We're seeing almost 200 people in the space right now, and everybody's using these tools to try to build something incredible. I can't wait to see what people build at the end of today. So right now, I'm about to do a workshop. We're going to talk about Weaviate and how to use Weaviate for the data ingestion process of vectors in order to do vector search. We're going to go through from ingestion all the way to querying in order to create highly engaging experiences for your users. Weaviate is going to provide highly contextual search information based on your queries, and that'll give your users a much more engaging experience. Well, why don't we jump right into it?
Okay, so I've got a few things to share about Weaviate today, and it's just a generally good tool to support search across the ecosystem. That includes anything from search in a recommendation system to search in a agentic RAG application. Weaviate can power all of these use cases for you. I want to talk a little bit about search before we jump into the world of technology, of programming, of code. Search is actually a tool that we use in our everyday lives. If we're at the coffee shop, we're searching through the menu to figure out what it is that we want to drink. If we're at the Costco, we're searching through all of the items that are wholesalely available to purchase. If you're on Spotify, you're searching for music, and if you're on Google, you're searching for information. So search is everywhere. And here are some examples where you probably have seen them all across the ecosystem. Wikipedia, Amazon, IMDb, music on Spotify. Search is everywhere, and it's built right into the apps and how we engage with them too. So, search in general is about knowledge management, and how you create that experience for your users is highly based on pulling in the right relevant information for them. And you want to have a good search system to support that. So Google search has been around for quite a while now. Haven't they solved it? Well, yes, they have. There's actually there's a lot of technology that goes into Google search, from PageRank all the way down to even vector embeddings to support semantic searchability. But there's more to it. And one of the challenges is that we don't actually have this search capability outside of Google. So how can we build around that? Weaviate actually helps you solve this by providing semantic search capabilities out of the box. And so, yes, search works, and it's fine, but we want to democratize AI and make search available everywhere. And so when we talk about search, we can do, the first thing that comes to mind is grep. Everybody's got grep on their laptops, and you can find basically anything based on the text you put in. That's basically keyword search. Keyword search, traditional keyword search algorithms leverage tools like BM25 or Best Match 25. In this case, keyword search is generally a good tool to start with, but sometimes you need more specific search types, and here's why. So I've got a query, why do airplanes fly? And this search result, why you should fly with expensive Air's airplane, actually solves that search query. It resolves that query because all of the keywords show up in it. You got airplanes, fly, why do, and this would satisfy the query. This obviously is not a great outcome for us because it's not the answer to why do airplanes fly. In this question, we care about the physics representation of how those two things fit together. So we want to figure that out, and we want to build a better system to solve this problem. We have something called semantic search, and semantic search basically solves this. It relies on the meaning of the text through vector embeddings. So why do airplanes fly? We'll yield something from NASA, for example, the dynamics of flight. Airplane wings are shaped to make air move faster over the top of the wing and slower over the bottom, which creates a pressure differential, causing this thing to lift. This is the kind of search result we want, and this is the kind of search result we can capture through semantic search. So yes, old school traditional search, semantic search is the new tool of choice. But actually, if you want to go further, you can combine semantic search and keyword search and weight them either one way or another in order to tune your search results. You could re-rank them downstream, and you can do a lot to tune your queries and make a better experience. Okay, so how does this work? Basically, we rely on this idea of an embedding model. Much like a language model produces the next most probabilistic token in the chain of tokens, the embedding model doesn't produce the most probabilistic chain of the next token in the chain. What it produces is effectively a set of numbers that semantically represents your input. And so if we want to like visualize this in a way, we can do something like color meaning. We can use RGB ratio in order to figure out how these vectors might look in three-dimensional space. Here's just a quick example. So 25500 is red, 80, 200, 120 is emerald, and they'll sit in three-dimensional space. Well, it turns out for these vector embeddings, we're actually working with machine learning models that can produce vector embeddings of like more than 312 dimensions, almost even thousands of dimensions at times. And that's why we need to provide a really highly efficient vector database in order to support management of all those vectors and actually queryability over that data set. There's tons of machine learning models and vectorizer providers from Cohere, Hugging Face, Mistral, OpenAI. You can even run them locally on Llama and some on Gemini too. So here's the idea. You're going to basically turn all of your data into vector embeddings. Here's one text. Fly with expensive air's modern fleet of airplanes to over 4 destinations. Why do you hesitate? Book now. That's one vector embedding. Pass it through the machine learning model to produce vector embeddings, and we get this new array. Next one, airplane wings are shaped to make air move faster over the top of the wing. When air moves faster, the pressure of the air decreases. That's our physics representation, our physics explanation. Pass that text through an embedding model, you get another vector. Now, one thing I really want to call out here and pay attention to is I'm passing in this highly unstructured text. It's literally 1 or 2 sentences per each one. This is what we call a chunk. And if you're working with like a massive book or unstructured paragraphs and paragraphs of text, or even scrape data from a website, what you can do is effectively chunk the text from those data sources, pass them through an embedding model, and now you have very searchable, unstructured data sets. You can do things that are clever, from overlapping the text to being thoughtful about how you break up the chunks. There's fixed size chunking, which is very straightforward. You literally have like 100 characters and you say every chunk is 100 characters. Or you say there's 200 characters with 50 characters of overlap on each side. These are very rudimentary mechanisms to supporting vector search through these chunks. It's called fixed size chunking and fixed size chunking with overlap. You can even go further with this and say, instead of fixed size chunking, I want recursive chunking, where you lean into the grammatical features of the language in order to provide your contextual chunks on each section. So what does that look like? You could say topmost priority for chunks would be punctuation of a certain type, periods or exclamation marks or question marks. What happens then is if the chunks are too big, you recursively scope down and make smaller and smaller chunks until the chunk size fits the chunk size of the vector database that you're working with, of your collection. So that's up to your configuration. And so that's another way of vectorizing, or chunking, sorry, and we call that recursive chunking. You can even do something called semantic chunking, where you pass unstructured text into a language model and then figure out the distance of that vector compared to the previous vector. And if they're very closely related, we consider that one chunk because the ideas behind those 2 sentences likely refer to the same concept. And then as soon as you have a chunk that is where the distance is much farther, we call that another chunk because the idea is sufficiently far enough or different enough from the first sentence or the prior sentence. Okay, many different ways of doing chunking. I'm not going to go too much into that because this is, I want to keep focused on this workshop, but if you're dealing with unstructured text, that's what you can do. Okay, all of these vectors are passed into vector space. Weaviate builds a really, really comprehensive index that allows you to search over that data set fast and easily, and from there, you can effectively do querying over it. What it means is all of the vectors that are clustered together actually have similar semantic meaning with one another. And vectors that are further away from another have semantically different meaning. So you could imagine airplane and dog will sit far away from one another in vector space. But airplane and helicopter might actually sit close together. These are clusters of data, and the clusters of data actually represent information that is more similar to one another. Okay, let's jump ahead. Again, general pipeline. You pass the text into an embedding model. The outcome is a vector. And then from there, the vector sits in vector space, and we can query it with high performance, low latency in Weaviate. Also, Weaviate supports multi-dimensional vectors and vectors of different modalities. There's many things you can build, and we integrate with basically everyone in the ecosystem, from OpenAI to Neo4j, Haystack, LlamaIndex, LangChain, Google, AWS, everything. We integrate with every tool out there. Okay, so I'm going to take you through the actual contents of this workshop right now. In Hacker Squad, you can actually get two things. One of them is the notebook, and you'll get that notebook right here. So if you click on this, it'll open up this notebook, which I actually have open right here. I'm actually going to skip loading that again. And I want to talk a little bit about this notebook and walk you through what to see. But before I do, I actually want to go create a new cluster for fun, because it's super fast and super easy. You click on this plus button, create cluster. This is going to take you into a screen that looks like this. This is a free sandbox. It lasts for 2 weeks, and you can renew it. You can spin up another one, and you can move your data over if you want. But once you start building, you really want to have one vector database cluster solidified for your data to go into and to build around. So let's build a cluster here. This workshop cluster. This workshop cluster is running 1.32.5 version of Weaviate. It sits in GCP on US West, which is right next to where I am, or roughly anyways. In terms of configuration, this is going to use auto schema generation, because that's a big convenience feature and it makes it really easy to build new collections. We're not going to do asynchronous indexing, but we will do asynchronous replication. Okay, pricing is 100% free because this is a sandbox. It lasts for 14 days and you can renew it. And there is a default disk size available for this in the free cluster. And also the embedding service, which we're going to talk about, which we're going to use, has a limit of 2,000. Okay, so let's go and create this workshop now and see what we're getting with this. So this is going to take maybe 1 or 2 minutes, but with this, you'll get a Weaviate REST endpoint, which we can immediately start sending data into. And then if you scroll down over to API keys, you'll be able to create new API keys. And this is what's going to allow you to authenticate with your cluster, store data into it, read data from it, and do whatever you want. I will let this thing do its work, and we're going to go update this in the cluster in a moment. Okay, jumping over to the notebook, the collab, there's a lot of resources in here that help you get started, but actually this is dependent on a data set that I've already ingested into Weaviate. And we're going to go take a look at what that ingestion process looks like. So as I mentioned, you actually need to create embeddings. And one of the features of Weaviate is that we integrate these modules into many embedding providers. And in this case, what I want to showcase is Weaviate embeddings, which is an embedding model that sits right next to the Weaviate cluster. Actually, I have a diagram here to show you what that looks like. And this is kind of that whole idea. You're the developer, you're building your application, you're making API calls to the Weaviate vector database. That's going to send in, that's basically going to be your queries and your ingestion pipeline. If you send in some JSON that you want vectorized, you can rely on this thing called Weaviate embeddings right over here on the right. And what Weaviate embeddings does is it's a server that runs an embedding model. It'll vectorize that data set and then send back the vector into Weaviate directly. It's super straightforward, it's super easy to work with, and it's super fast. Actually, if you go into the console right over here, maybe if I click on my prior one, you can actually scroll down and, okay, maybe not. Oh, we'll just jump in over here. We actually support 2 embedding models. We support Snowflake Arctic Embed Large v2 and Snowflake Arctic Embed Medium v1.5. What generally people say is that v2 large is good for multilingual data sources, and v1.5 is smaller, it's faster, but it's good for English and good for a variety of use cases as well. It actually performs generally well on benchmarks across other embedding models, and it's a great place to start if you don't know what embedding model to use. Also, because it sits in Weaviate embeddings, it's a huge convenience factor. It makes it easy. So how do you actually use this? Step 1 in working with Weaviate is always to create a collection. Actually, this is true for any kind of database. You need to create your tables. And what we call collections is effectively a table. So let's go in and take a look at what that looks like. The first thing we do, we go and grab the cluster URL and the API key. Then we initiate a connection request to Weaviate Cloud. We pass in the Weaviate cluster and the Weaviate API key, the same things that we get out of the Weaviate console, and that will instantiate a Weaviate client that we can interact with right in our code. Finally, we actually are doing this thing right here to delete the data just to test and make sure that we have not actually created the data before. And we also will print to see if it's actually connected. This script is to go and create the collection. So let's go actually see what that looks like. We have Weaviate embeddings books. And it uses Weaviate embeddings, and specifically, it's going to use the Snowflake Embed Arctic Embed Large v1.2. Some of these books are in other languages. Some of the descriptions are also in other languages. But this is the important thing to note. We give the collection creation function a name. We send it a vectorizer with a vectorizer configuration, and then that specifies the model that we care about. The generative configuration allows us to choose which models we want to use for RAG. So when we do a query to our vector database, we can also pass in a natural language prompt. The natural language prompt is effectively going to pass in that prompt plus the search results into the language model that we have configured here. And in this case, we're using Friendly AI's MetaLlama 3.3 70 billion instruct. This is generally useful tool, generally useful inference model as well, and I get it on the serverless endpoint. We can also create a variety of properties, and these properties allow us to define what the schema looks like. Of course, books have a title. Of course, books have ISBN identifiers, categories or genres, a thumbnail that we care about, a description that is highly important, number of pages, average rating, published year, and author is also important, but more importantly, like the description is what we want to be able to search through. Now, before I leave this, I want to call attention to this attribute right here, this parameter. I'm saying skip vectorization equals true. What this means is that when Weaviate vectorizes the data set for this, it's going to skip the ISBN identifiers because that's not really relevant for our search result. Or the thumbnail is also not that relevant for our search result. And same is true for the number of pages, the average rating, the published year, and the authors. These aren't as important as the description is and how the experience we're trying to build out with being able to search through the description. And so that allows us to stay focused on vectorizing the title, vectorizing the genre or category, as well as the description. And that's it. That's how we define our collection. And now we can start dumping data in here. And actually, that's what we're going to do in the next step. So we're going to use this populate function, or populate script. And what this does is we pass in the Weaviate cluster URL, the Weaviate API key. In a similar way, we instantiate the Weaviate client. You guys got to be getting used to this by now. The instantiation of the client is always the same with the Weaviate cluster URL and the API key. From there, we will get the Weaviate embeddings books that we just created. We created this in the last script. This is going to create the book collection, and that book collection now sits as a Weaviate collection that we can interact with through the client. I have a file in this repo called 7kbookskaggle.csv. It's a 7,000 book data set from Kaggle, and we're just going to load it into the Weaviate vector database using this for loop right here. So we're going to iterate through all the books. We're going to build out the dictionary or the properties of these books, where we pass in ISBN number identifiers, the titles, the subtitles, the categories, the description, etc. These are all of the same features of the collection we created, but the key items being the title, the description, and I think the category. So this is going to create that dictionary, and then from there we insert that data through the properties dictionary. And what's really awesome about this is we haven't actually touched vector embeddings at all. We just created a collection, we defined the Weaviate embeddings vectorizer, and then we started loading data into the vector database, and suddenly vectors are going to start popping into the database. We don't actually touch the vectors ourselves. We can focus on building our application. We can focus on creating the experience that we want to create. And we don't have to worry about the actual underlying pipeline to get this data into the database. It also allows us to benchmark our data faster and benchmark our retrievals faster, which is super, super important for building highly engaging experiences. Okay, so our data is now in there. In the remaining two scripts, I showcase, let's go click on that. In the remaining two scripts, I do a querying, and I also do another thing, but I forgot what that looks like exactly. So let's let this load. Just one moment, please. Okay. Yes. So we'll do a semantic search, and we'll do a generative search, but these are actually being done in my Colab notebook that I have shared with everyone, and I'll just start jumping over here so I can showcase what this looks like. In the notebook, what I'm doing is I'm actually using Friendly AI for inference, one of the sponsors of today's event, and in order to do that, you're going to go to Friendly AI friendly.ai. Once you're in friendly.ai, you can click on this button up here, go to your profile, and you're going to be given the ability to create an API key, or a token, API token. This API token will be expired. I'll expire this token right after this workshop, but I've already loaded it into Friendly, into my environment using my Colab notebook. Okay, so what does this look like? The first step is load in Friendly credentials. Next, set up the Weaviate client. You're going to say pip install -u Weaviate-client. That's going to load in all of the Weaviate client features in order to interact with Weaviate Cloud. Just like you saw before, I'm going to use Weaviate cluster URL and the API key, and we're going to connect to Cloud, which is where our cluster sits. We're passing in a Weaviate cluster and a Weaviate API key, and we also, this time, this is unique, we're passing in a very specific header called x-friendly-token. And we store that using we retrieve that using the environment variables that we passed this into. Whoops. And what this allows us to do is direct RAG with the Friendly features right with our Weaviate client. Okay, so now that we've instantiated our Weaviate client, we're going to check if it's connected, and we're going to check if we can even get our collection. So let's actually run this. We run this. So Weaviate is connected. We got a true answer. And now we're going to write our very basic RAG application with Friendly and Weaviate. Take a look at this. Step 1, import OpenAI. Step 2, replace the base URL with the Friendly AI serverless endpoint. Step 3, pass in the Friendly AI token, and we can define a function called callLLM. Now, this is actually using Friendly directly. It's not using Friendly through Weaviate's integration. If we get there, we get there. I'll show you what that looks like. But there's actually many docs about this on our website as well. So this is how you can use Friendly through OpenAI's OpenAI client. All right, we're all ready to begin. We can run this. There we go. And now we can start issuing queries. This is only going to do a query against the Weaviate books collection. And it's going to ask me a question, what would you like to query for in the books dataset? From there, we pass in that user query, and we limit it to 3. Let's limit it to 5 and see what happens. Let's hit enter, and it's asking us a question. What should we query here? Let's query for something like, I don't know, hackathon, because we're at a hackathon right now. That's going to instantiate the query. We've loaded that user query in here, and then here are the response. We're going to run this, and it's going to print each and every one of the responses. So Cryptonomicon in the beginning was the command line. CrossX, Robot Adept, and the voices of Moravath. I think these are pretty relevant and semantically similar to hackathons. Let's try one more. Okay, let's try biology. And what did we get here? Okay, we got to run this iteration. The phenomenon of life, animals, a short history of nearly everything, the science book, and essentials of conservation biology. Pretty relevant, all related to biology. I'm pretty excited about this because now it creates the foundation to building like any kind of application that needs a data set and be able to search through that data set. It's useful for querying through one user's data individually because Weaviate can create tenants, or you can create recommendation systems across all of your data. For example, if you have, let's say you have an e-commerce store and you're trying to surface highly recommended products to your users, that's a great way to do it. Okay, right here we are building a function called retrieve context. Okay, we're building out our basic RAG features here. We're going to return the query, and then once we get the response, we pass it into our recommended books, which is retrieved context. So let's run this function. Okay, we've saved it. And now we can build this function called generate response. And what this is going to do is it's going to allow us to pass in the Friendly client, pass in any messages that we care about, and then call the LLM function, which calls the OpenAI client, which points to the Friendly API endpoint. So let's go ahead and run generate response. And finally, we can build out the LLM chain. That's just a function that will take the retrieved context, pass the retrieved context into the generate response function. The generate response function takes in the user query, and then finally we return the response and we print it out. That's what this is down here. Did I run this? I did run it. Let's run this guy. Okay, what types of books are you looking for? I really like rock climbing and fitness. And what this is going to do, calls each individual function, does the LLM chain, then first it does the retrieval of context, then it does the LLM chain, and then it prints out our response, because the prompt that we gave friendly AI was you're a helpful assistant, reply to a chatbot message for someone inquiring for book recommendations. The user's query was what I typed in, and these are the books that came out of the Weaviate vector search. This is a very simple a very simple RAG that allows you to take your retrieve context, pass it into the language model, and then pull out a response. Let's see what that response looks like. It seems like the book recommendations I have for you might not be directly related to rock climbing and fitness. Oh, okay. However, I can try to make some connections or offer a fresh search. Okay. The books that came up in the initial search, Marilyn Manson. This could be a biography or a book about a musician. Okay, thanks. Even Be Doing This by Bob Newhart is a memoir by the comedian, which doesn't seem to be directly related to climbing. Okay. I guess there's not a lot of books that have anything to do with rock climbing in this data set, but if you put in relevant information, this type of query would be much more accurate. All right, that's it for this notebook. There's a lot that you can do with it, and I'm excited for what you build. I'm going to pull up one last thing, which is to show you the Weaviate and Friendly module integration. Weaviate Friendly AI module. And this allows you to do generative search right from Weaviate's client. And it'll make the friendly API calls for you downstream. Here's the high-level idea. Once you have your data ingested, once you're ready to do your queries, you pass in your queries and your prompt to the vector database. Weaviate sees that you're passing in the query and a prompt. We'll then vectorize the prompt so we can find the results for you. And then from there, we're basically going to grab the results, then take the results plus the prompt and point it at friendly AI, which is right here. We do the entire inference for you off on the friendly services, and then we send the AI output back. We send that back to you via the API call. The actual experience in using this is very straightforward. I'm just going to go down to look at this is the generative configuration. We're going to select a model at runtime. Yes, we can do that. But specifically, let's go find a query. Group task. All right, right here. This is a single prompt retrieval augmented generation. We go and grab our collection. We go and say, find me a specific near text or semantic search on some contents like this, pass in the single prompt, and then just from this, we have a RAG, and this is going to generate the output of the results plus the inference all in one API call. Huge convenience feature, makes it really fast to build, and you can start thinking about what you want your deliver to your users as an experience. All right, well, that's it for my workshop. I'm stoked to see what you guys do. Here, let me go close out this to the Weaviate embeddings architecture. I'm excited to see what you do with this. We are here until 6 or 4 o'clock. 4 o'clock is the project submission timeline. Thanks so much for listening. I'm really stoked to see what you build again. The energy in the room is incredible. Keep it up. Again, a little sorry about the Wi-Fi situation. We're still dealing with it. I think the Starlink came, but we still have some issues with it. But I appreciate everyone making do. The way that I think about this is we're in an environment where we're constrained on resources. Yes, and Wi-Fi constraints suck, but if you can get through this and win, the bigger the win is for you. That's how I feel about it. Thanks so much for participating. I'm excited to see what happens at the end of today. 4 o'clock is submission. That's when we do our raffle. We'll catch you in the meantime. Bye for now.